Here at Tactual, we're focused on achieving the goal of removing the latency and imprecision of today's direct manipulation user interfaces and making digital interactions feel more physical across three core areas. One is a set of innovations in the hardware sensor that relate to how you read and sense input in its raw form. The second is how to take the output from that very fast multi-touch capacitive sensor, which we call FMT, and to bring it into the touch processing and feedback stack and make that stack that exists in a modern operating system as fast as possible and able to handle the tremendous amount of data and events that a very fast, nearly lagless capacitive sensor would throw at an operating system. And the third area is user experience innovation, where we're focused on thinking about what happens when you remove all this lag and latency. What opportunities does that afford in user interface design to create new kinds of controls and mechanics in the operating systems and applications that we use every day?
At Tactual, we focus first on developing a fast multi-touch sensor. That multi-touch sensor is able to increase performance from traditional sensors, which often take 15 to 20 milliseconds to generate a signal after the user touches the system and to inform the software that the user has made that touch. Our sensor is able to work much faster in the order of fractions of a millisecond, ensuring that the instant that the user touches the device, the software is informed of that so that it can generate a response. Next, after that response is received by the system, we need to generate that response as quickly as possible. The architectures, both in software and hardware, that we are developing here at Tactual allow us to provide a response instantaneously. Traditional software, because there is software running in the system that needs to be processed in order to generate a response, takes time. The user gives that input, the system churns, runs through all of its computations to understand what visual response, what auditory response should be generated. Our system bypasses that software and ensures that every time the user touches, they get an instantaneous response from the system. Taken in combination, the multi-touch sensor, which delivers inputs at a fraction of a millisecond, then our new architectures that are able to respond to that input in fractions of a second, means that every time a display is ready to show a frame of output, we have new content for it to display. And what that means in effect is, the moment the user touches the system is the same moment that they receive feedback from the system, effectively eliminating all latency.
To achieve Tactual's goal of a zero-latency user interface experience, we're working on two fronts. The first is our Fast Multi-Touch Module, or FMT, which is a fully multi-touch screen that produces results within less than 1 millisecond, which is at least an order of magnitude better than anything on the commercial market right now. We're also working on TPU, our Touch Processing Unit, which is a method and technological system which will enable existing programs to still gain the advantages of a low latency user experience with little or no rewriting of their code.
So we have two products, FMT, which is the fast multi-touch sensor, and TPU, which is our software stack that tries to reduce latency. FMT will detect the millisecond someone touches the device. And that is basically saying whenever you touch the device, it knows immediately. That alone doesn't reduce the total latency. You need to then process that touch. The TPU does that with very little latency. So mixing the two together, you know when someone touches the device, and then you're able to reduce or show an output immediately using the TPU. You can use them separately, but for you to reduce all latency, which is our Tactual's goal, you need to use the two of them together.